2015 is about to come to an end, and some of the most exciting news stories this year came from the field of space research. And that's why we've decided to dedicate the program this week to planets and comets. Welcome to Tomorrow Today, your science magazine on DW. Buckle up, time to take off. The Sun is at the center of our solar system. The innermost planet, Mercury, is followed by Venus. Next out is our home planet Earth, then comes Mars and the gas giants Jupiter, Saturn with its rings, Uranus and Neptune. And out at the furthest reaches of the system is Pluto, which is so small that 10 years ago, space researchers decided it isn't really a planet after all. And now Pluto is called a dwarf planet. But that doesn't mean it doesn't have a lot to offer. In fact, the opposite is true. Last summer, for the first time, a NASA probe passed Pluto in a spectacular flyby, and it turns out that the icy world is geologically much more complex than expected.
Over the last 6 months, Pluto has surprised again and again. These images were taken by NASA's New Horizons space probe on its flyby of the dwarf planet in the summer of 2015. New Horizons was the first probe sent to study the distant reaches of space that are home to Pluto and its 5 moons. The voyage took nearly 10 years. Pluto's orbit around the Sun lies at the very edge of our solar system. Even the Hubble Space Telescope in orbit around the Earth could not resolve the surface. The dwarf planet was simply too far away. The new images astonished the researchers. Pluto is small, only about a third of the size of our moon. But the surface is wildly varied, with crags that rise 3,500 meters into the sky.
So these are pretty substantial mountains. They'd stand up respectably against Rocky Mountains or other significant mountain ranges here on the Earth. But we want to see a lot more about the distribution, and we're just getting so much data soon that right now we're still scratching our heads.
Planetary geologists believe that the mountains are made of frozen ice. It is still not clear whether any of Pluto's surface features are made of rock. This area also presents many mysteries. It can't be more than a couple of million years old because it's smooth. There are no craters left by meteors. Pluto is changing. And its atmosphere is also more complex than expected. It has layers that produce chemical predecessors to some of the building blocks of life. The new image we're acquiring of Pluto has revived an old discussion.
Hold up the yellow card.
Around a decade ago, the International Astronomical Union revoked Pluto's status as a planet, downgrading it to dwarf planet, even though American astronomers protested. It was the only one of the original 9 planets to be discovered in the U.S. All the others were discovered by Europeans.
The New Horizons mission is now setting course for its next goal. In 2019, it's supposed to reach object MU69, which is part of the Kuiper Belt, the ring made up of tens of thousands of chunks of ice and rock. That includes Pluto. Those results are certain to be exciting, but they probably won't eclipse news from a much nearer planetary neighbor, Mars. NASA wants to put astronauts on the red planet by 2035 and then bring them back again. That's not self-evident. A private initiative based in the Netherlands is trying to sell one-way tickets.
Over 220 million kilometers away from Earth, the wastes of Mars. NASA wants to send astronauts there by 2030. The Mars One project wants to make the trip years before that.
Mars. We won't just be visiting planets. We'll be staying.
200,000 people applied to take part in the planned Mars One mission. They all wanted one-way tickets to the red planet. In the end, 100 of the applicants made it into the final round. Among them Robert Schröder from Darmstadt. The 27-year-old studies electrical engineering and is specializing in robotics.
As a child, I always wanted to take a trip into space. I'm a scientist and also very curious. This is a once-in-a-lifetime chance to go to Mars and remake humanity and society.
So Schröder might be one of the first human beings to ever set foot on another planet. But how realistic is the Mars 1 mission? What does it take to get there and survive? Air, water, food, and protection from radiation are all musts. Then, of course, you need a spaceship.
At dawn, the dawn of Orion and a new era of American space.
NASA is currently developing a rocket that's meant to fly to Mars and then return, the Orion. It's made up of a transport vehicle and a smaller lander module. The trip there and back again will take 2 years and cost around $50 billion. The Mars 1 mission is much cheaper. Its planners estimate a one-way trip would cost just $6 billion. It foresees new rockets every 2 years that bring more settlers, living modules, and supplies. The goal is to establish a permanent colony.
It's an insurance policy for humanity. If the Earth were destroyed by something, then we'd have a backup where people would live on.
But life on Mars would be hard. Heavy radiation and temperatures averaging about minus 50 degrees Celsius would force settlers to live underground. They'd also have to grow their own food to survive. At the Institute of Space Systems in Bremen, scientists are testing greenhouses that only require light and water. The astronauts are the source of their own organic fertilizers in a closed-cycle garden designed to provide fresh produce on long space missions.
Calculations show that you need about 60 to 100 square meters to produce enough food for one person. One problem is setting up the right environmental conditions for the plants. And of course, the technical systems are still not fully mature. Pumps in particular are not set up to handle constant use. Our pumps break every 2 to 3 months.
Schröder believes problems like this can be solved. He says he'll be taking tools as well, and the sun also shines on Mars. And water and oxygen can be extracted from the frozen soil, at least in theory. The Mars 1 organizers want to finance the gigantic costs through the sale of television rights, a kind of survival camp against the backdrop of the Red Planet. So the idea of colonization isn't entirely illusory. Settlers could, in principle, survive autonomously on Mars. Robert Schröder knows that a mission to Mars would be dangerous, but says that's no reason to believe he can't go.
When Christopher Columbus set sail over the sea, he also didn't know if he'd ever be coming back.
Though there's one big difference. Even the greatest explorers in history could always hope for some kind of help along the way. Or in a worst-case scenario, they could turn around. But if Mars 1 goes ahead, the colonists will truly be on their own, over 220 million kilometers away.
And here to tell us more about the obstacles that have to be overcome to send astronauts to the Red Planet is Ulrich Köhler from the German Aerospace Center. Thanks for joining us. Now, what about you? Would that be something for you to take a trip to Mars without a return ticket?
Well, not without a return ticket, but for a geologist, of course, Mars is the target to be. I mean, it's the most interesting planet in the solar system, which we definitely want to investigate.
Okay. And you personally, you would also go for a trip like that?
Well, 2 years return trip is a long way, so I would really think about it, let's say it this way.
And the Mars 1 trip, so this one-way trip, do you think this is really going to happen? Is that realistic?
I cannot answer this, but we all know that space programs of this dimension are extremely complex, and also there's a lot of soft factors that are very difficult to overcome, like illnesses and psychological topics and all these issues. But the biggest problem is, of course, to get all the infrastructure run on Mars, and nobody has done this before, so I'm very skeptical.
What's the key challenge if you wanted to set up a base up on Mars?
Well, it's the harsh environment on Mars. It's extremely cold at night, it has harsh radiation, it has no ingredients for everyday life, so we have all to bring with us and to produce it there, and nobody has done it before robotically, so a big challenge, so to
Yeah,
say.
I can tell. But the first experiments are actually taking place, as we've seen. But do you think that one day it might be necessary for humankind to actually emigrate, to colonize another planet?
Well, it's so far away that the sun will blow up to a big red giant. It's billions of years away, so we cannot say the least about this period. So definitely Earth will vanish in some days, but whether this will make it necessary to get for humankind on Mars, I doubt that.
The bigger risk probably is that we ruin Earth and we need to take off.
Oh, we will take care of Earth, I'm sure about that.
Okay, so give us another hint on Mars, why it is so special and so important to actually send a person up there to find out more secrets about this planet.
Well, most interesting is maybe that we can look into the past of our solar system, and this also includes looking into the past of our Earth. We don't know why these planets developed so differently, why the Earth became so environmentally friendly for life and Mars didn't. Did life ever exist on Mars too? So these are maybe the most fundamental questions on Mars.
Thanks up to here, Ulrich Köhler. As we leave our planet to explore the solar system, another exciting topic is comets. Planning a mission to one is no simple task, not least because they often follow gigantic elliptical orbits, like Churyumov-Gerasimenko, or 67P. For over a year, the Rosetta mission and the Philae lander have kept us on the edge of our seats. The mission has cast a lot of light on these mysterious icy bodies. We talked to a key figure at ESA to find out more about Rosetta's many exciting discoveries.
Andrea Akamatsu is the director of flight operations for the Rosetta mission. At the end of the day, he carries the responsibility for its success or failure.
Well, I've spent 18 years of my professional career working on this project, and of course it has become part of my family. I think it's every day, I think of Rosetta, even though nowadays I don't work every single day on Rosetta, but I think of the spacecraft every single day. It's like a baby within the family. The biggest challenge of Rosetta has been preparing to characterize the comet. What does it mean? Well, we had to develop engineering models of the comet itself to be able to fly around it, to select a landing site and to land. But this we could do only the moment we were at the comet. So those 6 weeks, when we arrived at the comet, the first 6 weeks were a nightmare for us.
It was the first attempt ever to place a probe in orbit around a comet and send down a lander to its surface. People all over the world were captivated by the spectacle in space.
But I must admit, the one that raised the strongest emotions in me was the day we came out of hibernation. This was almost 3 years without contact with the spacecraft. I was pretty sure the spacecraft would come back, but there was nothing I could do. But for the hibernation, we had to fully rely on the spacecraft itself. And this was an explosion of joy, for sure.
Churyumov-Gerasimenko condensed from a cloud of gas and dust that is older than our solar system. The comet is now losing some of that material again as it heats up on its approach to the sun, ejecting it from the surface in huge fountains. For the last few months, the orbiter has had to keep its distance.
Now we are again at distances where we could have a radio contact, so we are waiting for it to appear. But of course, we don't know exactly how Philae is doing. We don't know it very well, so we are just listening in. If Philae wakes up, then we are ready to pick up the signal. Let's see.
At the end of the mission next September, ESA will try to land the Rosetta orbiter on the surface of the comet as well. During its descent, it will take many more highly detailed images.
Doing missions that approach these small bodies, comets and asteroids, what is very difficult is first approaching them and then orbiting them, doing operations close to this body. Their gravity is extremely weak, and this makes the whole thing much, much more difficult.
And Andrea Akamatsu might one day be able to use the results of the mission in other ways. He says if an asteroid was on a collision course with Earth, what his team has learned from Churyumov-Gerasimenko could help divert it.
Ulrich Köhler, it would be a sensation if Philae really woke up again. What kind of scientific findings could be gained if that happened?
Well, there's quite a lot of data certainly stored on its recorder. And we could get this data and get more interpretations on what's going on the surface of the comet. That's most exciting, to get this data.
On the surface, while it was actually circling close to the sun.
Correct. We have to go on distance with the orbiter now, and now we're approaching again. So we set the feeler lander what he should do when we're gone. And so maybe we get new data, new measurements, new temperatures, and new magnetic field measurements. All these data could be stored to the orbiter.
Okay. What were actually the main scientific results that this mission delivered?
Well, there are, of course, quite a few, but I think most important is the result that the water of our oceans on Earth is probably not coming from comets. At least these type of comets have a different composition of water, and that was quite a surprise to us.
Could you, I mean, was that ever imaginable that we had enough comets delivering the water on planet Earth?
Definitely. We have billions of comets still today in the solar system, out in the very far distant areas, in the Oort cloud and in the Kuiper belt. So if you count these impacts together, there would be enough water for filling the oceans of the Earth.
Another idea was actually that life was brought to Earth by comets. Could Rosetta actually solve that riddle?
I would say it would not be life that has been delivered, because it's too cold for life to exist on comets. But the ingredients of life, like carbon-hydrated molecules, they are part of comets. And this is still an idea that it's vivid. But so far, Rosetta has not yet get this result really confirmed.
But is that probable for you, that life didn't really come to existence on Earth, but somewhere out in space on a comet?
It's probably the biggest questions we have to our solar system at the moment, whether life started here on Earth, or whether it came from somewhere abroad, or whether the ingredients at least came from abroad. So this is a big discussion in science, and I think there are quite a few Nobel Prizes in that.
The total cost of Rosetta was around €1 billion. Was it worth it?
Absolutely. I mean, it's €4 for every European citizen. Is that much?
Thanks a lot for the talk, Ulrich Köhler. Space travel nowadays isn't only about new goals. Many old ones remain fascinating. Researchers, for example, are now very interested in our moon again. India, China, and Russia have all started ambitious programs to put people there within the next 20 years. And the Europeans are even dreaming of building a base on the moon. A viewer from Nigeria has a question about our closest celestial companion.
Oh, just Daisy. Oh. Hello. Nice to see you again. We've been receiving lots of exciting questions from our viewers.
Christian Emachida from Makurdi wants to know, how is the moon important for the Earth? It circles us day and night. The moon is the Earth's constant companion. In cosmic terms, just a hop, skip, and a jump away. A mere 400,000 kilometers. The moon was probably created when another huge celestial object slammed into the primordial planet long ago. Since then, our only natural satellite has been circling the Earth and having important long-range effects. The play of gravity between Earth and moon drives the tides. And the moon also slows the Earth's rotation. Without it, the planet would spin 3 times as fast. Days would be just 8 hours long. But perhaps most important of all, our satellite stabilizes the Earth's axis, a prerequisite for a stable climate. So the moon plays an incredibly important role in life here on Earth, and it will be our first stepping stone in further manned exploration of the solar system. Researchers are planning bases they hope to build there, along with settlements and factories, in pursuit of valuable mineral resources that are in short supply here on Earth.
If you have a question, write us by going to our website. See you soon, and don't forget, the most important thing is to never stop asking questions.
That's right. Send in those questions, and if we answer your query on the show, we'll send you a copy of our Einsteinchen DVD as a thank you. And now we've got something very special for you. German astronaut Alexander Gerst and his fascinating insights, photos and films. The geophysicist was up on the International Space Station for 165 days on what was called the Blue Dot mission, a reference to the fragility of our home planet. And his images tell the story of a very emotional journey.
It's the most incredible view imaginable. The cupola on board the ISS, 400 kilometers above the surface of the Earth. In 2014, the fabulous backdrop helped turn astronaut Alexander Gerst into a media star. Hundreds of thousands of people began following him on social media.
It really is our best module. If we didn't have it, it would be a lot harder for us to work up here. Without the module, we wouldn't have this unique view outside. 360 degrees around you and 180 degrees looking down at the surface. It's fabulous.
The International Space Station orbits the planet 16 times every day, moving from light into darkness every hour and a half, then back again.
The cupola points downwards from the station towards Earth. When you float into it head first, then initially everything is upside down. It feels like the Earth is floating there above you. That's especially impressive at night. I always had the feeling that when you're on the night side and the Earth is floating over you like this dark ball, especially over the Pacific, where there are no lights at all, it always felt a little like the Death Star from Star Wars. Sometimes it even felt a little threatening. When you fly over Europe at night, it's this sea of lights. You can identify each individual country from the outline of the lights alone. Stop and think about it. 200 years ago, it was all dark, all black. Now the planet is actually brightly lit on the night side as well.
Gerst did what any of us would have done. He looked for the places that he knows, places he's lived, like Christchurch in New Zealand.
I think that picture is one of the best ones I've ever taken in my life. It has this incredible complexity. I can look at this picture for hours and still keep finding new things in it. I think that I find it so impressive because at a single glance, you can see how perspective works with us, how it helps us. If you're standing on the beach in Christchurch and asking yourself why the water changes colors 4 times a day, you probably won't be able to figure it out. But when you look at this picture, it instantly becomes clear. You can see that rivers carrying glacier sediment from New Zealand's southern Alps are being dumped into the sea, and they swirl around this peninsula, the Banks Peninsula, and cause these vortexes.
Beauty and destruction. Images like this one also fascinated the astronauts' followers on Facebook. They show corridors hacked through the heart of the Amazon rainforest. Suddenly, everyone could see the scale of the destruction with their own eyes.
We should take each of the participants in the climate conference up to the space station and let them look out for an hour. I think that then some geopolitical decisions would turn out differently.
The Facebook community posted and reposted the spectacular images Gerst took of auroras. He had a bird's-eye view of the natural phenomenon.
The green isn't static, it flickers. It stretches from one horizon to the other, and from up there, you can see regions that are thousands of kilometers away. These waves would pass through at incredible speed, run across the whole sky in a split second. It felt like I was looking at a living organism. I always had the impression it was alive.
Fans loved the astronauts' photographs. But he didn't only take pictures and films of our planet's natural beauty from space. He saw terrible things as well.
I actually only saw it by chance. I flew by a window and saw something that I couldn't place immediately. There were these dots down on Earth that suddenly started to move. and every once in a while there'd be this flash. I didn't know where it was at first. And then it slowly began to dawn on me that I was watching people who, at that moment, were killing each other before my eyes.
Gerst was witnessing the launch of 100 rockets from the Gaza Strip. Israeli air defenses managed to bring them down just in time. The images from the ISS have helped change perspectives of people all over the world. Like no one else, Alexander Gerst has shown the beauty and fragility of planet Earth.
We're only tiny lights in a vast cosmos, after all. We shouldn't view ourselves as too important, but at the same time, seek to preserve what we can. I'm Ingolf Bauer for Tomorrow Today. Thanks for joining us and take care.